Okay, we're going to look at problems 16 through 20 on the 2015 June Geometry Common Core exam. So looking at number 16, you want to write these things down here. So all of these things about dilation, some properties that we have talked about. Remember, dilations are not a rigid motion transformation. So keep that in mind. That means when you dilate a figure, the size and shape do not necessarily remain the same. The distance between points is not preserved. Right, so now let's look at the question. Make sure you write down the things I asked you to write down. But let's look at the question. If triangle ABC is dilated by a scale factor of 3, which statement is true of the image triangle A prime, B prime, C prime? Well, let's see. Which statement is true? So only one of these statements is true. The other three are false. So first off, we know that the scale factor is greater than 1. So your new figure is going to be bigger. So which one of these is true? Well, looking at number 1, or answer choice 1, it says 3 times A prime B prime is equal to AB. That's not going to be the case because A prime B prime is already bigger than AB, right? It's already 3 times as big. Now, if number 1 had said A prime B prime is equal to 3AB, now that'd be different. That would be true. But the way they wrote it, it is not true. So that is not an answer. All right, looking at number 2. B prime C prime is equal to 3BC. Well, that is definitely true in this case. Because you know that, remember the image, which is indicated by the prime symbols that you see, which are the little symbols here, the image is 3 times as big, which means every side is 3 times as big. So that means that B prime C prime is 3 times as big as BC, so that is our answer. We can look at the other ones. They are obviously not true. The angle is not going to change, so measure of angle A prime is not 3 times measure of angle A, and 4, same thing. The angles do not change, which is right here, this part right here. The angles after you dilate do not change. Well, we'll move on to the next one. All right, I decided that I wanted you to write down a couple of things for problem 16 to help you. So what I'm going to do is draw a triangle, which I did. I put some points down here. So that makes a triangle, and we have A, B, and C. Now I'm going to do a dilation of 3. So a dilation of 3. Now, if you recall, when you do a dilation, you simply multiply the points by the scale factor. And the scale factor in this case would be 3. So my A prime would be 3, 9. So I'd have to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so that'd be my A prime. All right, now my B prime is going to be 6, 3. Because remember, you're multiplying these points by 3. So you're multiplying 2 and 1 by 3, so you're going to get 6, 3. So 1, 2, 3, 4, 5, 6, by 3. And that's going to be B prime. And C prime is going to be negative 6 and 3. I'm going to go 1, 2, 3, 4, 5, 6, 1, 2, 3. All right, so we have that. And that's C prime, and as you can tell, That is a bigger triangle there. And all the sides are 3 times as big. The angles are still the same. Distance is not preserved. All right, so make sure you have that on your graph paper. All right. And number 17, it says Steve drew line segments A, B, C, D. A, B, C, D, line segments look like this. Line segments, A, B, C, D. E, F, G, so where's E, F, G? That's down here. And B, F, and CF. So this is BF, and this is CF, as shown in the diagram below. Scalene triangle BFC is shown. So let's see. I'm going to have you write something down. So stay tuned, and I'll be right back. All right, I want you to write down the definition of scalene triangle, which I have put here. Let's look through these answers. It says, which statement will allow Steve to prove that ABCD is parallel? Remember those little lines being parallel to EFG. So, how will that be proven? Which statement? Well, let's look at these statements. Number 1, it says angle CFG. CFG would be this one. And angle is congruent. Remember, that means congruent to FCB. So FCB is this one. And if you remember, what types of angles are the ones in green? If you said alternate interior, you would be correct. So these are alternate interior angles. So alternate interior angles. Right? Since they are congruent, that means these lines are parallel. So that is our answer right there. All right? Number 1 is our answer. Okay, looking at the question number 18, it says in the diagram below, segment CD is the image of AB after a dilation of scale factor K. They don't tell you the scale factor. And then with center E. So what we do know is this is the image. And this is the pre-image. So think about this. Did the scale factor have to be above or below 1? Think about that for a second. All right. Since the image is smaller than the pre-image, you should have said that the scale factor is below 1 or in between 0 and 1. So that's just a little fact there. Now we're going to see what the answer is. Which ratio is equal to the scale factor K of the dilation? So let's look at these. What about EC over EA? So that's going to be this segment, EC, divided by this segment EA. Well, if you have that value should be under 1, because this distance versus this distance, if you have this distance on top, then obviously that's going to be less than 1. Even if we don't know the values, we know it's going to be less than 1. So that could be an answer. What about BA? What about BA over EA? So BA over EA. Well, BA is longer than EA. That's going to give us a value over 1. We don't want that. That's not going to be our answer. EA over BA. That is not what we're looking for. EA over BA, that's not what we're looking for either. That's not the relationship. And EA over EC is obviously going to be greater than 1. So when you're looking at this, when you talk about the corresponding points and you have your center, the ratio is going to be EC divided by EA. That's going to be our ratio. That is equal to the scale factor of the dilation. All right, let's look at problem number 19. It says a gallon of paint will cover approximately 450 square feet. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? So let's talk about what is a cube. It has six equal edges. And 6 equal faces. You guys know what a cube is. We've talked about that. All right, so if the edge of a cube is 12 feet, let's write down something else first. All right, so let's write down 1 gallon of paint is going to cover approximately 450 square feet. All right. Now, each face of the cube, is going to be a square with all the sides being 12. So you have to imagine this thing having 6 faces, and I'm not going to try and draw. You know, you could start to maybe see this if I kept going here. Okay, those of you in my class know that my drawing's not my strong suit, but you have 6 faces to the cube. Each one is 12 by 12, so each face is 12 by 12. So to paint one face of the cube is going to be 12 times 12, or 12 feet times 12 feet, which is going to give us 144 feet. But that's just for each face. And that's going to be square feet, each face. All right, if it has 6 faces, we're going to have to do 6 times 144. So 6 times 144 is equal to 864. So we have 864. Okay, so that's square feet. All right, now each gallon of paint can cover 450. So 1 gallon will not be enough. Will 2 gallons be enough? Well, 450 times 2 would equal 900 square feet. So 2 gallons of paint would cover 900 square feet, and that would be enough to cover our 864. So our answer is going to be 2.